Morning, folks. As the giant word suggests, I'm going to be chatting about workflows using open source standards. The specific standards we're talking about are BPMN and DMN. Does anyone here already know BPMN? Show of hands, we have a few. Okay, anyone know DMN? That's decision model notation. We got one, fantastic. So someone did some homework, great. So I'm just going to basically be showing you guys how these standards can be used to really easily sort of create a lot more infrastructure for your projects. So workflow can mean a lot of things, but in this case, we're actually going to talk about how it can really be used to help you avoid doing additional work, reinventing the wheel when it comes to projects. And for that, we're going to think up a project to maybe do. The very beginning of this is going to be a few slides, and then I'm going to go into just building something. So again, if you have any questions, if we have time at the end, we'll squeeze them in. But also, I have a booth out there somewhere, so if you wanted to, you can come ask me stuff. So first of all, let's think about a generic project that we can consider, just hypothetically. And this project has a selection of users and systems, and they both need to be called at different points for different reasons. So we have systems and users, so we need a UI that's visible. We also need system calls somewhere in there at certain periods. So we need to make some decisions about how we actually decide to go from those. Where do we keep the state? We also need to wait for messages that might come in. External systems could send in messages to say, hey, here's a response to something you asked for, or maybe, hey, you can continue doing that. And while we're actually waiting for those messages, we need to maintain some consistency. There's also points maybe where we have to wait for a certain amount of time. Let's say you send out an email and we need to wait, let's say 3 days before sending a reminder or something like that. So there has to be some sort of way of asynchronously being able to wait for a certain time to expire or for a certain condition to become true. And this is something that needs some sort of infrastructure, some sort of way of dealing with it. And then also, depending on certain events that may occur throughout our little project, or specifically data that might exist in a certain way, we'll actually be routing the routing of the process kind of differently. And of course, finally, we also need to take care of all the fun stuff like an event that could occur at any time that might change how things work. This can be everything from an error that might occur at any time in our process to something like, hey, we have a condition or a message that has come in that changes everything. So the nice thing about all of these things is that, first of all, if you were given this as a project to sort of say, hey, look at this, these are your requirements, before we even talk about business logic, actually what this project does, these are the things that we need to make sure we implement. And the nice thing is that using workflows, you basically get all of this very easily. So this is the BPMN model. Okay, and this shows visually sort of how work is distributed. In here we have if I have my cool little red pointer, we have a task that a user can do. Okay, we also have a system task here. Okay, and it's still visual so far, and we also have something else over here. We can also handle events. We have here a timer, so I may need to wait for a specific time period, or I may actually need to wait for a duration or a date in the future. And here we have an event as well, where we wait. And we have, in this case, we can handle these events happening at any point. And the engine and a workflow is able to maintain that state. We can also do asynchronous processing, which is massively important. If we start this process, we want things to be asynchronous. Okay, we want to be able to do things in the background or do things maybe over multi-threads or something like that. And of course, the thing that we get that we didn't even know we needed is visibility. So what I'm going to show you guys in a few minutes is that this is not a diagram. This is not documentation. BPMN 2.0 is an open standard by the OMG that is a visual representation of an executable model. Okay, meaning that when you build this, there is XML that an engine can read to actually turn this into your own state machine, depending on what you put in there. And the visibility is one thing, because I'll be able to see where everything is, where all my processes are, what's going on, but I'll also be able to do things like this, which is if I have a very complicated process, if I have thousands of instances that have run through it, what is the most common path through my process? That is what's seen there. And that's a very easy thing to figure out if you're using an engine, because every single step along the way is all maintained in history, and it's always maintained in the state. So now for the example, we're going to actually think of a project, some sort of little project I can think of that has interaction between people and complex systems, sending messages and waiting for replies, rules that need to be checked, because I'll talk about business rules a little later on. Also waiting for time to expire, like let's say for instance 2 years, or depending on if things change, like election results for instance. So there's one really nice process, and I usually like to try and find something topical. So a process we're going to actually try and model is Brexit. Anyone heard of Brexit? It's this really cool process that the UK are doing. Really, not massively popular, but it's got some pretty serious rules in there. It's got some very distinctive flows. It's got events that may occur, whether anyone wants them to or not. So we're going to actually start and just build this and execute it and show you how it works. So let's do that. So I have Eclipse open here, and you'll see it in a second because my screen has been a. There we go. Okay, so fantastic. So I've created a project. So I used, this is Eclipse, other IDEs are available. You can use whatever you like. But in this case, I'm going to use Eclipse to control my project and all the dependencies revolved around it. So right now, I built this project using Maven archetype. So it's a very basic project, nothing additional needed. You just build it with Maven. You don't even need Maven if you don't want to. So next, I'm going to open up this guy here. This is a modeler for the standard, okay? So as soon as I click on BPMN model, we can now see that we have a little start event, we have a palette, we can now start building. And once I start building, in the background, this stuff will be generated as we build. And this is the stuff that's important, because this is the thing that's executable. So it means that as an analyst, let's say, I can go ahead and start building this in this conventional way I'm used to, but the problem is that now an analyst has to do their job a little better, because now this actually runs. Because previously, you might have come across scenarios in which analysts would use some sort of bespoke modeling thing that is in a document somewhere that gets handed to developers and said, hey, make the code do that. Okay, this is a very different approach. This is saying what you guys design is what is going to be executed. What I'm going to do is just write the business logic. As a developer, all I need to do is actually write the real stuff. So let's kick things off. So this particular process is started with a message event, and that message is, and remember the name of the article? Article 50. Good job. Okay, so article 50 arrives. And that's how we begin this process. Okay, so next up we need to do two things. First of all, we need to do multiple things in parallel, because we need to wait for a time to expire, because unfortunately, there is a time limit to this process. So I have a parallel gateway here that will go on in this direction. In the meantime, though, while we're doing that, we will actually in parallel be waiting for a time to expire. Okay, and when that time expires, we will actually end the process. We will use a terminate event, which is presumably here. Okay. Anyone know how long we have to wait? 2 years indeed. Someone's been reading about the news. Okay. So 2 years. So we will be waiting there happily for 2 years until eventually things go out, unless the process ends before then. So next up, we need to find out who's left in the EU. So for that, I'm going to use a service task, meaning that I'm going to run some sort of custom code that's going to find out who is left in the EU. Okay, and the reason we're doing that is because we need to ask them for some sort of negotiation strategy or whatever. I think everyone has to agree, so we're going to create a service task, so a user task, and with agree on, and this is a word that I can't spell, so I literally copied it and put it in here, on negotiations, great. And because, of course, that this needs to be given to absolutely all members of the EU, this actually needs to run in a multi-instance, meaning that when we get here, this task will be run the amount of times equal to the number of EU people. Which number is? Number of EU countries that would need to do this task? 27, perfect. 26, well, not yet, let's not get pessimistic. So 26 people need to do this task. So once we actually agree on something, we can then go into what I'll call here a sub-process. Specifically, there we go, I'm reusing the copy-paste. And the negotiations process can happen now. So now we can actually do some work. So now I can actually say, okay, in these negotiations, we're going to need to do 3 things. The order in which they happen, we don't really know. We know that we need to decide on, agree on trade, or trad, yes, trade, which is, again, some sort of user task. We also need to agree on, let's say, on citizens. So agree on citizens still living in whichever EU or the UK. And then I think the final one is the one that hurts the most, the divorce bill. Okay, because that's the thing that needs to happen. So what we're doing here in BPMN is I've decided to have these 3 things will become active as soon as we get to this point. Okay? And they'll all be run in parallel. And any one can be completed first, it doesn't matter. They're all just available to be completed. But once all 3 are completed, they'll all wait back here, and then we will finish the negotiation stage. Okay? And then for now, I'm going to just say that we end the process there. So we're done. I'll come back to that a little later on, though. I will expand this model because it gets a little more complex than this. So now I've done what essentially you need to do as an analyst or somebody who is developing a process to know something about. So in this case, I've done nothing that needs any technical expertise. Okay? But now I actually would, let's say, okay, I have all this beautiful XML. I'm now going to give this to a developer, and he is going to put it right in here in a project. So let's grab this. And I'm just going to save this file. And it's going to be called, of course, Brexit. And I'm going to give it a name. Okay, there we go. Okay, so now I actually am in my project now. Okay, so if I refresh this, I now have my lovely little thing, and it's part of my project. Hope you guys can see that. Is that too small? I think it's all right. And now I need to look at this with different eyes. I need to look at this from a developer's perspective. I have to take this step by step. So the first step is that we are waiting for a message to arrive. Okay, now this is something that you might think, okay, we need to deal with how queues work. We need to deal with how to actually intercept this. But the engine kind of has that already. So all you need to do is give it a name. So let's say, call it a Brexit message. Okay, so that's all you need. So a system will send a message to the engine to say, here's a Brexit message, and the engine will say, oh, looks like I have a process that needs that to begin. So that's that done. Next, I need to decide who's in the EU. There's lots of different ways actually to implement this, but because we are using Java, I can directly attach a Java class to this. Okay, so I'm going to select a Java class. I'm going to go to my project where I have already kind of done that. That's the wrong one. Yep, there we go. There's a simple little class that just has all the names of all the EU countries. What it does is it basically says, so add all these countries to a list, and then I want you to give that list. This is the context of our process instance, and I want you to give this variable to the context, meaning that I can then use it anywhere else in the process. So this is going to give a list, and we're going to use that just now. So all I need to do is copy this guy here, and then add that. Okay, next up, things are a little more complicated. I'm going to need to create a multi-instance. And interestingly enough, the multi-instance means that I want to run this task for each country, and I want to assign it to that country too. Okay? So what I can do is, I can say, okay, well, I know I'm going to have a variable called EU countries, and it's a list. So I'm simply going to say, use that list, and the engine will say, for each member of that list, I'm going to just spawn an instance of this task. I'm going to choose a country as the element, so the element of the list. And finally, I'm going to say, and assign this task to the specific country. Okay, so once more, I just decided to take this variable that is generated in the previous task. Each element is a country, and I'm going to assign the value of that as the assignee. Okay, so far so good. Now we need to add this. I'm going to make things a little more drastic, and I'm going to create, how much I'm going to say 20 minutes, PT 20. So I'm giving this a duration. So this timer can have lots of possibilities. We can actually have a date in the future, a duration, a cycle time, a cron time, whatever. I'm going to use this format here, which says PT20M. So it's going to be 20 minutes, from now, or from the moment I actually launch it. So next, I'm going to go into this little negotiations. And for this, it should be known that your process should be an orchestration layer. Orchestration is the important part, okay? So you don't actually want to embed too much stuff in this. UI is a really good example of that. What I'm going to do now is, oddly enough, not what you should do, but this is just the quickest way of doing it. I'm going to actually embed the UI in the XML model by simply creating form fields. So I'm going to say this one's called trade, and it's a Boolean, and the label is, does the UK have access to the single market? Okay, question mark. Okay, so that will come up as a user task. Divorce bill is a little more complicated. We're going to add another form field, divorce, and it's going to be a long, and it's going to be how much does the UK have to pay? Okay, and finally, agree on citizens. So this is just citizens, and it's a Boolean, and can people stay living where they are? Okay, so that's pretty easy, and then that's kind of all you need to do. So that's it, essentially built. Now the things I didn't go near are important. The parallel gateway I didn't touch. Why? Because the engine just knows what to do. It doesn't need any interference. It doesn't need anything. We didn't need to do too much about how this task here, I didn't do anything. I'll show you why in a second. And so now I can probably just deploy this. So I'm going to refresh this, and I'm just going to, first of all, build it with Maven. Now, right now, in the meantime, I have this guy running in the background. So this is a Camunda distribution. Camunda is a process engine and a front end and the modeler. It's an open source project, and it's right now running off a Wildfly distribution. So you can have like Tomcat or anything else, but in this case, it's Wildfly. And this is what's going on. There are 24 process instances running. There are 5 processes deployed. And assuming great, what happened there? Okay, that's fine. I forgot to do a very important thing, which is skip tests. Okay, I'm actually going to deploy straight to Wildfly. I'm going to be very confident in my ability to make models, so I'm going to say, I'm sure it's fine. So the testing part is important because you can actually step through the entire model before deploying it using Java, and you should. Just, yeah, hey, build success. See? Skipping tests works every time. So now if I refresh this, we should see on the right here, if I log in correctly, we now have 6 processes deployed, and one of them is called Brexit. Okay, and there it is. There's the thing we created. So now let's actually start some stuff. So the first thing I need to do is I need to actually get a message in. So let's pretend to be some external system. And here is Google's nice little REST client. I usually use Postman, but this just looks prettier, so I decided to go with that one. And this is just talking to my local host, and it's sending a message, and that message just needs to have a message name. And in this case, our message name is going to be Brexit. Okay, so if I send this message in, it should be able to start that process. Okay, that's good sign. That very sort of unconcerned face means that if I refresh this, we are now, okay, we now have a deadline to reach. In fact, what's happened now is we have 27 instances of that one user task, and we also have a deadline of 20 minutes, so let's get started. I also have created this. This is another front end for end users, so this is where I can view tasks and complete them. If I click on this one, it'll just show me Brexit tasks. So you can see we've got a lot of them. We got Slovenia there, Spain's task, and you can see that they're assigned to the specific country because I used that variable. So I could, let's say, go through each of these and complete them, but I probably won't, because that's a lot of work. So instead, I shall usurp democracy in a certain way, and I'm going to actually use some admin tools to sort of play around. The first thing I'm going to do is, I'm pretty sure everyone agrees. I mean, Europe generally does, so I'm just going to say cancel those. Okay, so cancel those 27, but also create a new token before negotiations. Okay, so what I'm doing is I'm manipulating the state in a really, really complicated way. I'm saying every single token you see there, the 27, indicates a state. A process instance can have lots of states constantly running in parallel. And in this case, I'm just saying remove these 27 tokens and remove those tasks associated with it. And instead, I want you to create one token, which is what the little plus here is, at the very beginning of this. And I'm taking 27 away from here. So I click Apply Modification. This says you're playing with fire, because we definitely are. And click Proceed. Okay. So now what's happened is we have scooted across, and we're now at this point. Okay. So what happened was we created a token that would have started at this point right here, and therefore arrived in this subprocess and then created 3 parallel tasks. How that's affected our task list is like this. Those tasks have disappeared because the state has moved on. And now we have a divorce bill, we have this and this guy here. Okay, now there's one quite complicated thing I haven't decided to add to this yet, and that is I haven't added an agreement. So we have the ability to say that Britain has agreed on trade or not, or agreed on citizens or not, but we've no actually method of deciding whether we actually want to go on that. So I'm going to head back to this model, and I'm going to add that additional check. I'm going to make sure that after these negotiations, we can decide to renegotiate. Okay, so I'm going to, after this, we're going to need a task, and this is going to be a business rules task. Okay, and this is going to be decide on deal. And then we're going to have a gateway right after it. And this gateway is deal agreed. And we have yes. And over here is, we actually just go back and do that again if there's no agreement reached. Now, this is an important little box here, and I'll show you why. In BPMN, we can do loads of things really, really, really well. Okay? We can have state, we can manipulate things going forward, but in BPMN, rules are, you have 2 options really. You have this in BPMN to define rules, which really doesn't work very well, and the other option is you have this mystery box. Okay, and up until around the end of 2015, this meant some business logic somewhere does something. Okay, and what happened in 2015 to change that was the aforementioned, we got a few more standards from the OMG. We got DMN, this is decision model and notation. And they decided, hey, BPMN seems to work really well. It's entirely visual, it's executable, it's maintainable by end users. Let's do the same thing for rules. Let's try that. Now, this was not an attempt necessarily to, let's say, replace rules engines and decision engines. Instead, it was more of an ability to say, hey, we have this specific group of people who need to maintain rules, need to change them relatively frequently, and also don't want to have to call a developer every time these rules change. Okay? And so we have something like this. This is a DMN table. So this is an independent standard and an independent artifact. So it can be called externally, and it can also be called from a BPMN model itself. In this case, we have a bunch of inputs, which are generally in the context of the current process instance. We have a bunch of rules that it then checks against, and then, of course, we have some sort of output. Okay. So ever since then, it's basically, if you're using open standards and using open rules, the idea is, don't bother with this, implement it in this, using this. Makes sense, okay? It's visual, it's really easy to maintain. So I'm going to do that right now. I'm going to change my process a bit. So this guy here, now I do have options. I don't have to use DMN. I can use a Java class, and I, in fact, have already written these rules in Java. So, but I think DMN is the best bet, and to that I'm going to start. I'm going to build a DMN table. So let's do that. DMN. This is decide on. Let's copy that lovely word again. Fantastic. Okay, there we go. And this is going to be, it's going to have multiple inputs. We have 3 specifically. We have trade. We have, let's say, citizens. And we also have divorce. Okay, and in the end, we have agreement. Okay, can everyone see that okay? Yeah. Okay, so now we just need to just define what this is. So trade is actually going to be a Boolean. It's either going to be we let them or we don't. Citizens is going to be the same. Either we let them or we don't. And divorce is going to be more interesting. It's going to be a long. Okay, and the agreement is also going to be a Boolean. So now these are the inputs and output. Now I need to add some rules to this. So let's just pop a few here. So first of all, if they say yes to trade, and yes to citizens, and the divorce bill, let's say, is equal to or greater than 19 something, that's a cheap divorce bill, then we're going to say, yep, no problem. That's an agreement there. And if, let's say, they have trade, but we don't, citizens can't live there, it actually doesn't matter how much they promise to pay, it's just a no, let's say. And then we can also say, if this is no, and this is no, and the divorce bill, let's say, is greater than, let's say, 2,000 or something, then that's also yes. And then we also have a default of no. So the bottom line, so what I've just done here is I've said, by leaving this blank, it just basically says, doesn't matter what the input is, we're going to just go with this. So the very next thing I need to do is actually select a hit policy. So this determines how the actual table will give us our results. The first thing is the default is unique, meaning that every single rule must be unique. And we will check every single rule, and then as the one, either one is valid or there are no rules that match. It's the only 2 possibilities. The one I'm going to use is actually first, meaning that we're going to go through each rule individually, and the very first one that matches, we return. So order is really important to this, which is why we can have a default. Alrighty, so now I'm just going to do exactly the same thing. Just so you know, this is also represented in an open XML standard as well. So these are all transferable. So the things you create in DMN is transferable to any other engine, or transferable. It's in a standard that is intended to be traded between software and engines and modelers. So let's find the name of my resources again. Oh, actually, one more thing is actually I need to, yeah, let's just put it in the thing. So this is, again, this is what the analysts have done. And this is Brexit decision. Okay, so this is what an analyst can do. They can do all of this. This doesn't require any code at all. So now we actually have to go back and look at this as a developer again, and we click this lovely button called Enter Advanced Mode. So you feel really good about yourself when you click on that. So there's a decision. We need to give it a key, a name. So it's going to be decide on Brexit. And we need to give it actual variable names. So trade, citizens, and divorce. And finally, agreement. Okay. And that's it done. And this is now part of my project. So now I should be able to add this table to my model. And so I'm going to go back here. I'm going to say, okay, we're going to use a DMN table. We're going to call it by name. So it's the key associated with it, which is presumably here. Okay, so call this. And now we get some interesting stuff, because we can decide what version of this table to call. So by default, it'll say latest. We can also say the one deployed to this process. We can also specify a version that we want. And that's our own version. That's not Camunda's version. That's your own. So it can be whatever you like. And I'm going to go with latest. And then we have a result variable, agreement. And now we just need to change the execute this gateway, because if we have some sort of agreement, we go this way, and if we don't, this will just be a default. So let's change this to default. Okay, so if we agree, we go this way. If not, we return back. So let's save that and let's redeploy it. Let's see, run as. Again, I'm going to be very brave and skip tests. We'll find out pretty soon if I mess anything up. Possible. There's a pleasant surprise. Okay, so now let's refresh what we currently have. Now, as you know, we're currently running all sorts of stuff right now, and I've just redeployed stuff, and as you can see, this has affected the engine in no way whatsoever, because why would it? Meanwhile, if we take a look at what's currently running, nothing is actually affected by the fact that we now actually have a second version of our process, which is this one here. So we are now running two versions of the same process in parallel. And if I start a new Brexit process, it'll actually start this new version always. So, which is not so useful for now because we're in the middle of negotiations, so maybe starting from scratch is a good idea. So instead, I'm going to just migrate the instances from the old one to the new one. So we'll just map them across, and we can sort that out later. So this is saying that it's going to map this one to here and this one to here. You don't have to do that. If you want, you can say, you know what, actually don't bother mapping that one, or map it over here instead. But I think for the safety of the talks, we should probably keep them the same. So I'm going to click this. There's only one instance, so we'll migrate that. You can do it asynchronously if there's like thousands and thousands of them we want to migrate, but I don't need to bother with that. And there we go. And it's migrated. So, okay, so then we have our Brexit process is now, there we are, we're in the new version. Okay, and the nice thing is these user tasks are actually not affected. Along with migration, we also brought along the IDs. So if you had a front end that was completely independent from this, it would not even need to know migration happened. It still has exactly the same call to make to say we're finished. And that's true as well of migration in general. So first of all, let's say that how much we want to pay, let's say 30. Let's say, let's see, people can't stay, so let's complete that. Oops, didn't add 30. So I'm going to complete that. So we've got one left, we're on trade, and I can refresh this to see that, okay, we still have one more to go, and then we can sort of claim this and say, nope, no single market, am I complete? Oh dear, they all came back, so that didn't work out too well. It worked out exactly as planned if you like the rules, and in fact we can check out exactly what happened because we can follow the history of this instance. So I can actually see, okay, what path did we actually take? And we can see that I went here. You can see I basically cancelled all these before. We can then see that we've arrived here twice. We arrived here once, and then we went around here. And here's why these business rules are so much better than hard-coded, because I can then check out, why did we make that decision? Why was it that we decided to renegotiate? And we can kind of see, oh, okay, well, it matched this bottom rule, which is a default of no. So they were false on trade, false on citizens, and only 30 quid. So it wasn't really a very great deal. So that's why this table then returned this agreement, and we routed the process accordingly. Okay, so now let's actually try let's try a better negotiation tactic. So let's go with a load of money. Yeah. Let's say that agreement is reached here. Yeah. Oh, I didn't actually add that again. Oh yeah, I also see that the variable is repopulated because we still have the same context. So let's say it's 2000 or something. Complete. And claim this. And hey, look at that. Do we have any more tasks? No, we don't. So I can go back here and refresh. Okay, and now we can see that we've reached the end here pretty easily. Meanwhile, of course, we also have the 2 years is still waiting. So we're still actually waiting for that to expire. So that'll stay there forever, I guess, unless I decide to end it. But the business rules themselves are sort of, can be a lot more complicated than this. This is a very basic table. And I'll really quickly show you how this becomes really interesting by clicking on this little button here called Show DRDs. I'm calling one table from here, okay? From here, this guy here. And if I click on this button here, I then get this little view, which is the little box. And this says Decide Negotiations. Now, why it's important is because now I can actually create dependencies on other tables. So I can say, if this table gets called, the first thing you should do is call this table. And then it'll run that automatically. So funnily enough, nothing actually changes from here. This is still calling that table. But if you actually go in and decide in DMN to decide, hey, this table now has a dependency, to figure out something about the input, we're actually going to run this other table. Okay, and then we can also, and what will happen is if you run this in the engine, it'll end up going back and looking for all dependencies. So I could also call this one here independently. And it has no dependencies, so it just runs. So this can mean for very, very complex decisions can be maintained very easily by breaking them up. And the reason we want that to happen, and we want small tables, is because if we actually take a look in Cockpit here and take a look at our decisions, which are here. Okay, if I wanted, if let's say our position changed on our negotiations, the nice thing about DMN is that you can edit it in runtime without actually needing to deploy anything. So I can actually go in here and say, you know what, let's not do the 20,000, let's just do the 20, it's fine. And and then I can proceed and then actually deploy this. Okay, now what that changes is not the current anything that's already run through it. That has already been locked down in history, in the audit, saying at this time, from this process, we call this version of this table, and that is maintained. But the next time any system or process asks for this table, they'll get the newest one. And you can leave that to be maintained really easily if there are things that change quite frequently and that developers might not be called in for. Okay, so So the bits and pieces and tooling you can actually use for actually achieving this entirely open source is by using these two standards, BPMN 2.0 and DMN 1.1. It is transferable, so you can be very happy to build these in these standards and of course transfer them if you want to change anything. It's easily understood by the business. Both are designed to do that. So it's also executable, of course, which is really, really important. We also have an open source and free modeler. The thing I use there is entirely open source and really extendable as well, so you can feel free to mess around with it as much as you like. We also have a web-based modeler if you're interested in that. That tends to be favored by business folk. You can do things like, I don't know, have two different people working on the same model at the same time and so see changes. That's pretty cool if you want to check that out. The desktop modeler, the one I was using, was actually, it's intended as a developer tool, okay? So it's the tool that you would use if you were actually adding that stuff. That's why it has that properties panel on the right. The web-based one doesn't. It's entirely geared towards analysts and designers. And then, of course, you need an engine itself, which is, in this case, Camunda's engine, that actually runs these open standards. So all of this is entirely open source and easy to use and easy to just get your hands on. The engine itself, if you're interested, I happen to have been using the engine as an embedded, as a deployed to a container, but that's not the way you have to use the engine. You just happen to be the easiest one to display. The engine itself is a little, I think it's 4 megs now, a little Java library that you can embed in your own process, in your own applications, and then call entirely via Java. You don't actually need to have infrastructure for this engine if you don't want to. I happen to use it because it's more useful. The REST API is built on top of it, and all it needs is a relational database, and it's really easy to cluster. What we actually just saw was this, which is where the engine itself is deployed to a container. It has some sort of database for maintaining state. And we also saw Cockpit and Task List. These two things are front-end applications written in AngularJS, and they just communicate using the open REST API. So you can tear them out and put something new in. It doesn't really matter to the engine and the modeler as well, of course. So the thing about, so what I've shown you so far is being able to build a model and manipulate it in runtime, right? I've been able to show you guys how you can really easily do that. But a thing that people tend to kind of forget is stuff about how much information you can actually get out of just using a process engine. And for that, I love using this example because it's just true. Here is, if you decide to go to, decide to be interested in, let's say, a quote for the enterprise version, which exists, you would go to our website. There's a lovely form you fill out, and this then starts this process internally in Camunda. And this process currently has 13,000 instances that have run through it. So what we can see is something really easy like this, which I showed you before, which is the frequency, the most common path through your process. Now, if you're a sales guy, and it's probably at least one in the room, this is not good. There's 7,000 sales that are not made, essentially, what this is showing. Instead, we would much rather they show up here, where these very lucky 253 people have decided to end up. And we can also see stuff like really simple things like duration. Hey, how long do we spend on this process? What is the most, where do we spend most of our time? And we can see here is a call activity. This is another sub-process, so I can click into that, and I can say, okay, why do we spend time in this process? So in the end, this is very basic data. This is just reading the audit. This is just reading what is happening when a token moves. There's nothing too complex about this. But if you want something that's a little more complex, we can go into here. And here is the same model, but we want a more nuanced view. We now know that we actually lose sales through this thing here, I guess. Okay? So most of the time we go down here. Okay? But now we want to know what's the difference between the ones that go down here and the ones that actually arrive here at this point. It's a really important question. So what we can do is we can say, okay, let's analyze this model and let's select a node in our process. And I've selected this guy here. There's 383 that have gotten this far. So now I can say, okay, let's take a look at the factors. I can look at how long the user tasks took in this particular case. I can check who specifically was working on those tasks, for instance. But a more interesting one, and one that's more sort of useful for developers, is what were the variables like? Like, who were the actual people? What information did they give us? So we can say something like, okay, let's take a look at their industry. And this is an example I love to show because it's really key. If I can zoom in a bit. Can you guys see that okay? I'll read it out. So here we have, these are this guy here, the one on the right, shows every single process. 14,000 instances, everything is just there. So we see that we have lots of people from consulting start this process, a few from finance, one or two from insurance, lots from a very popular industry called Other. Must look into that one. Public administration as well, a software vendor, and telecommunications. So these are all the ones that start. On the other side, on the left side, we have the 383 that made it. And the really important thing is that if you were to just look at, hey, who's going to our website? What industry is most common? You would not think that insurance is in any way useful. But actually, it turns out that finance and insurance are the most likely people to get that far down the process, right? Now, this isn't just bragging about how great we are with finance and insurance, although I probably should. Instead, this is showing you that if you give this thing data, you don't need to do anything else than just ask for it back in different contexts. Okay? You can do a lot of really, really important information. And you saw me very, very easily and quite quickly change and deploy a new model in a couple of seconds without actually affecting no downtime and easy runtime. And that's another important thing. We want people to analyze and update and deploy new processes often. And our engine is geared towards that. Okay. So, yeah, that's kind of the stuff I wanted to discuss. So, the last thing to say is just that we do have a booth out there to chat to me if you want. I'll open it for questions in a couple of seconds. Also, there's we were looking at trying to let Scandinavia know that we have a cool open source engine. So you'll probably see that there's a little ticket in your bag with an offer for Scandinavian customers to get I don't know, I think it's a workshop day or something for a certain amount of money. More information from the sales guys. I shouldn't be talking about that sort of thing because I'm not sure what I'm saying. So, but there is some sort of deal for Scandinavians. The next thing, and so before I say goodbye, any questions so far? Or any questions at all? Yeah. Yeah, that's a very important question. Well, you see, we don't want to like oversupply the market, so we went with 5. It's a good number of colors. Also, and something that, if you're interested in colors, something that might interest you, and this always excites business people, is that I can make this any color I want as long as it's blue, orange, green, or these colors here. Look at that. Isn't that amazing? Yeah, that's very special stuff. So, yeah, any other questions? Yes. Yes, they are indeed. The modeler is entirely open source. There's no enterprise requirement. They model BPMN, DMN, and CMN. What they model is, it's important to know that the things we've added to the modeler are not about the engine. What I mean is, like, I can put, for instance, this symbol. If anyone knows BPMN, can anyone tell me what this does? In BPMN, this does magic. This just says, whatever you like, that symbol will do it. It's useless. It has no actual execution abilities. So this modeler is not about talking to the engine. It's about creating correct BPMN 2.0, irrelevant of what the actual engine happens to do. So it's very easy to use, and you can transfer it to other engines or not. Super. Any other questions? Nope. We're all good? Fantastic. Well, thanks a lot, guys.